Very pleased to be back again. Let me recap what I shared with you this morning. In terms of workload, we have close to about 500 engineers that they spend close to 20 hours a day in the lab building these basically solutions, putting servers, storage, networking gear, software. And the goal is to, if you look at multiple tiers that make up a solution, you have a storage, you have different way of connecting the storage into the server, you have different level of operating system or kind of operating system you can put on these machines, different middle tier application. Then there is a whole management stacks, multiple choices. There is enormous number of possibilities that you could extract from this hierarchy. Our engineering goal is to, considering the cost, considering the performance, considering the viability of the technology, select instances through this hierarchy that is optimized for a given application. Not only select the right instance through the hierarchy, selecting the right storage, the right way of connecting that storage to the server, selecting the right server, selecting the right operating system or software on the server, as well as the right way of connecting that complex to the end user and the right way of managing that. Not only selecting the optimized instance, but also on the way flushing out all the do's and don't and take that information, make it available to our customer base such that we will take the pain, we will take the headache of discovering those. And hopefully we will discover them before our customers will do that. When I set off to do these solutions almost 10 years ago at Dell, my goal was to use the Dell engine and know-how and augment that engine. We used to call it direct model. We still kind of call it that, but let's call it the older way of doing business, augmented with the right capabilities such that I can deliver more complex stuff the same way. Now, in order to do that, that means I have to do a lot more work up front in the engineering organization. So let me share you some of these practices, how we have set off to achieve that goal, to take the cost of the complex solutions, take the complexity out, and be able to deliver that much more effective way. Whereas competition might sell you a solution and then throw in 2,000 engineers and technicians on site after the solution has been sold to make sure it would work and to optimize it and so forth with your cost. Our strategy is different. We want to do as much of that work up front such that we don't spend too much time at your site trying to make this stuff work. So in that regard, the solutions that, as I indicated, we have been focusing on, we look at them as sort of the workloads or applications, and we think of multiple possible containers where these applications can run on. They could, is that noise me or is it in the back of the seat? So good, there's no there's no statics in my voice. Anyways, the containers could be a physical container, could be a virtual physical combination, could be strictly virtual, could be a cloud, which is basically in-house or outside of your organization. So our goal is to, when we do these solutions, these workloads, to make sure we consider all these containers. Now, not only considering the possibility of all the containers, but also migration across these containers. Also overflowing from one container to the other on need basis. I'm not saying that we have figured all of these out yet. There is a little bit more to do, but clearly that is the view, that's the strategy. And we have made significant accomplishment in that regard. So throughout the discussion, the next 25 minutes or so that I have, I will actually share with you some of the workloads and what kind of work we have done when we qualified those workloads on these containers, and what kind of sort of differentiation, sort of improvements have we seen as we went from our 11G to the 12G. That's another important factor. Now, this improvement could be in terms of performance, could be in terms of power consumption, could be in terms of ease of installation, could be in terms of ease of management. These are all things that my engineering team look for when we have a new building block, such as our 12G server that we have to take into these different workloads and solutions. So let me see if I follow a few slides for you. Clearly, to run an IT, you need to have a proper infrastructure, physical servers, storage, networking. You need to have ability to life cycle manage these workloads. Workloads, the code from, let's say, database layer could change. The operating system could change. The revision is made to the new version of the relational database engine. You need to be able to have an assessment, quick assessment of the impact of that on the rest of the solution, the totality of the solution. And you also, it's ideal to be able to provide these services in as much of an automated way as possible to the end user. So our framework for our vision of a data center of the future is you have good amount of automation at the infrastructure level. You have good amount of tool and automation for workload management, lifecycle managing the workload. And you have good amount of automation for self-serving the IT to your end user. Think of there be a portal where different classes of users have been identified as the users of this portal with the allocated amount of sort of capacity that they can take out of the IT infrastructure. And if the end user, for example, an engineering person needs another additional, let's say, computing power because he or she is trying to run a new simulation model, be able to access the portal and be able to specify which group the person is with and be authenticated and actually kick off the installation of that application that would allow the simulation run to be performed. Sort of do all of that without intervention of any IT administrator. That's basically our vision of the future of the data center. And we have building blocks that currently support that framework. So, as I indicated, the infrastructure is very important. One thing that will be basically launched in India a few days down the road is this thing that I talked to you this morning, which is the building block for a virtual basically environment. Is sort of, think of it as the smallest sort of private cloud, fully integrated, contained with Microsoft Hyper-V or VMware ESX and the right server and right cabling and connection to some of these management, enterprise management frameworks, such that you could use that, which comes all cabled and so forth, to deploy your workload on, or multiple of that to build a bigger, basically, cloud. That's sort of the first installment. We are also working on incorporating application into this framework, such as collaboration applications, such as databases, and so forth. So that's related to the infrastructure. These are the kind of things, solutions that we are creating, appliances, if you wish to call them that are related to the infrastructure. In terms of when we say working on a workload or being able to deliver the workload properly, clearly it takes more than just engineering to deliver that. We don't have all the building blocks ourselves. We partner with the best of the best. That's the notion of alliances. We have strong alliances with Microsoft, with VMware, with SAP, Oracle, and quite a few other ones. We have a very strong organically grown and inorganically grown services organization. That's another key component. I'm kind of this box right here of this total end-to-end capability that is needed. And of course, you need to have the product, the building blocks, such as the 12G servers. Our goal is to basically give you this solution, whichever piece of it you want. Clearly, we have the capability to give you the full piece. But if you already have other pieces or you have the internal capability, we can give you individual components, such as the 12G servers. We can give you reference architectures, what building blocks to select and how to put them together, and what are the right ways to interconnect in these building blocks, and what are the things to do and not to do, so you can accomplish that yourself. That's the notion of reference architectures. We can also provide you with pre-engineered, prefabricated building blocks, such as this private cloud, smallest private cloud in a rack that I talked about, as well as we can give you on-site services. So the point here is that there are sort of the a la carte menu. We can give the solution components or the totality or the know-how to basically build, or we give you additional resources, manpower, to help you do that as well. And this is what I want to talk about. I mean, my team not only makes sure the end-to-end solution is optimized and so forth, it also creates a lot of reference architectures. And these blueprints are designed such that you could expand them or you could shrink them. For example, if you go to dell.com/oracle, using that as an example, you see reference architectures for 2-node Oracle rack, 4-node, and you can actually expand that into about 64-node theoretically. But what we have tested it and qualified and can attest to is about 32 nodes. So, and I'm sure 64 will also work. But the point is that these reference architectures come with some amount of flexibility, so you can tune it to fit your need best. So let me quickly go through these slides. I want to get into specifics of some of the IP, some of the differentiation that we have flushed out as far as these workloads and the 12G. So for us to do the full workload solutioning, powerful alliances, a strong engineering team, and a very intelligent infrastructure. This chart here kind of shows as you get pieces versus getting the full-blown services, the amount of effort that you have to go through is basically decreases as you go from left to right, and the amount of expertise that Dell has to bring to the table basically increases as you go from left to right. In terms of when we talk about workload, again, these are the components that we pay a lot of attention to. As I indicated to this morning, even us that do engineering, we try to mimic what our customers' environment could be like or what they could go through. So to the extent possible, we use some of our own, or the expression is eat some of our own dog food or some of the good food. For example, as I indicated, if my team needs more resources to do the engineering work, we tap into our services cloud that will give us the infrastructure and the application and so forth, especially if we need that thing for a short period of time. We want to use it and then return it instead of me going buying all that equipment. Similarly, we have virtualized quite much of our laboratory environment, so we can very quickly deploy more larger configuration for testing, scalability testing, and so forth. In other words, we're using extensively virtualization, not only in our IT operation, but also our engineering product development environment. I told you about the use of social media to get the information out to our customers as quickly as possible. These are examples of how we're using, we try to mimic and benefit from using the environments that our customers, what we advocate to our customers. So, already talked about these. Let me just move on to some of these solutions. With the 12G, the kind of workload or solutions that we focused on, collaboration, which includes Exchange, SharePoint, naturally SQL, because SQL comes with SharePoint, high-performance cluster computing to build a supercomputer with 12G and other building blocks. Also, databases such as Oracle and SQL, database solutions. Also, virtualizations. Certainly, the servers, the 12G machines, they have ability to run hypervisors in a very optimized way. We also have taken these machines and put them into appliances that will be the building block for private cloud, such as our the rack that I told you about. Also, integration of the 12G into our AIM product, which is basically physical and virtual infrastructure management, provisioning and management environment. Our Viz product, which has a sort of flow engine integrated, where you could specify the workload that you want to deploy, and the system knows in order to do that workload deployment, what additional capabilities, what infrastructures you need, and what additional basically capability you need to activate. 12G product has gone through the evaluation qualification of all of these solutions, and there are more solutions that are going to be delivered, such as ERP, SAP, and so forth. They are not available or ready yet. So with that, let me kind of advance forward, and let's look at some of these claims that I want to show you. Here, this is for the HPCC. That's the high performance cluster computing. Look at the bottom of the slide. With the 12G, we can achieve order of magnitude, basically flops, number of floating point operation per second, but 30% or so, 2 times flops, more flops, and basically about 30% more speed with the 12G. Again, how did we drive at numbers of this nature? Well, my engineering team, they have executed a typical benchmark like LIMPAC and other ones. We have a slew of benchmark that is used in this space for bioinformatics, for oil and gas, for example, for related to computational fluid dynamic design, things of that nature. And these are the numbers or performance improvements that have been flushed out of the solution. Now, again, this is compared to our prior generation, for example. For SQL, that's another basically workload or engine. These are some of the claims that we can make with 12G. 50% better transaction per second and 30% better application response time when our R720, that's our rackable two-socket machine, compared to the similarly configured R710. This is sort of the older generation. So we do, this is an example of where we have done generational, intergenerational or intra-generational comparison. The latest generation of the machine, the server, with the prior one. Or when you put in PCI Express Flash, you will see the performance improvement on 12G under this workload. An example of improvement. Here is some statistics or some improvements that were flushed out. Again, we just didn't do the theoretical calculation to figure this stuff out. We actually performed end-to-end solution execution, basically application execution and observation, monitoring, and comparing it to the older generation of machines. Here is under Oracle, when you have Cachegate with Oracle 11G, we get 28% better response and about 3 times the number of concurrent users. Again, because what went inside the 8th generation machine, there is a good amount of caching at the controller level, and naturally there is more memory supported on this machine, faster chipset, and that results. This is the impact of this improvement at the building block to the basically application, in this case Oracle engine. Similarly, when you use our Rackable 720, that's the 12G machine, with the compellant, that's the compellant storage. The data progression gives about 86% reduction in response time and up to 59% throughput. So again, this has to do with the storage connectivity of the R720 to the SAN, to the compellant storage subsystem. And when we also go back, if it makes sense, couple of generations. And the reason, like for example, this comparison at this last bullet is comparing this 12G with our 2950 is because we feel that there are customers running 2950 today, which is kind of 1 or 2 generations back, and these machines might be ready to be replaced. So we want to make sure we provide the performance gain or the advantages when you replace the 2950 with basically the latest generation machines. These are some statistics related to that. Also, the kind of statistics that we like to collect, which we believe are naturally useful, has to do with the generational aspect, or is between the generation of the software, major software. For example, as Microsoft transitioned their Exchange product from 2007 to 2010, we wanted to make sure we assess the impact, the performance, and the ease of installation and so forth from 2007 to 2010 as we go from basically our older generation of servers to the 12G, the latest generation, because we felt that there are customers that are running Exchange 2007 on the older generation of Dell platform. The new generation of Dell platform is available. The new generation of Microsoft Exchange is also available 2010, and they haven't migrated yet. So that probably is a good time to migrate not only to 2010 Exchange, but also migrate the server as well. And also flush out, if they do migrate to 2010 and the platform is not migrated, would they still see all the benefits that 2010 brings to bear? Because sometimes if you transition the upper tier and don't transition the bottom tiers, you might not get the benefit, that additional values that the upper tier brings to bear. So these are the kind of things that my team does. You know, we try to think very practical. We try to put ourselves in our customer position. So what situation they might be in, unless when we do these workload analysis and qualification and so forth, make sure we flush out these good to know kind of pieces of information. Here is some statistics on the collaboration. So for example, our 720 with Hyper-V can support 130% more collaboration user compared to our prior generation 710 with a similar usage profile. So you know that collaboration, when you get into the Exchange, into the SharePoint and so forth, there are profiles, there are classification of users into office workers, or in case of the SharePoint, search and other user profiles. This is an example of performance benefit you get. There are also, as we have done, these are just samples that I'm showing you so you get a better feel. There are also statistics and so forth that we extract, we discover related to the power and cooling. One of the metrics that I have made sure my engineers start or have started evaluating is the basically power per computation. What is the watts per flop, for example? What is watts? How many watts per transaction, for example, per second? These are the kind of metrics that I believe are very close to the customer language of problem or challenge, and being able to relate these together. So if I come to you and say, well, this thing uses 20-30% less watt, well, so what? I mean, tell me, how does that relate to my application? So the other claim here, the 720 XT, that's the machine that has quite few internal drives, I believe 24 drives, if I'm not mistaken. This machine also lends itself very well to run Exchange 2010, because as you probably know, Exchange, the later version, are really designed to benefit very much from internal storage and not depend on the external storage. And this is the machine that was designed with that in mind. So another point here is that as you look at the architecture of these servers in the 12G product line, they were designed with a specific workload or set of workloads in mind. The 720 XT is a version of 720, but with quite few internal drives, was designed with Exchange 2010 in mind. Here is example of a claim that we were able to extract for high-performance cluster computing. Basically, 175% increase in sustained gigaflops with integrated GPU. We actually offer GPGPU with these machines, either on a PCI card or on an external box that we have, the 410X, that's the external box that can take this GPGPU. It's like a PCI extension box, and you could load it with GPGPU, and you could assign a different number of GPUs to the processor, to the socket on the main server. 1 by 1 or 2 to 1 or 4 to 1, and very scalable and dynamically configurable. So when we put our 12G into high-performance cluster computing workload or solution, we also incorporated GPU, and this is an example of the advantage that we were able to see, calculate, measure, flush out. So with that, I'm about a minute or so under. So let me just summarize. Our focus is creation of evaluation, creation, delivery of full solutions. And in order to do that, these building blocks, as we build them, like our 12G, or as we acquired a storage company like Compellant, or we build our next generation of direct attached storage, our MD product line, like 3210 and so forth. We will take these building blocks and we put them in the solution stack, and we select the right permutation of the building blocks through the hierarchy. And it's not only that we qualify, make sure these pieces work together, but also providing a lot of tools. I give you an example of a tool, an advisor. For all of the solutions that we do, there's an advisor online. So remember, dell.com/advisors, and you will see the list of advisors for these workloads that are available, and you interact with this advisor, and it gives you a recommendation in terms of number of servers, what kind of server, storage, how to be interconnected, what software, and so forth. And actually generates a solution ID which you can take to your salesperson and have further discussion. The system will pull that recommendation out based on that solution ID, and that kind of could be the basis for a discussion to see whether that will fit your need or not. As well as a lot of information in a consumable way. We just don't dump the information online. We try to If it is a technical piece of information that could be communicated, we take it out through a technical blog, hoping that our customers' technical community will be connected. And the Dell Tech Center, that's the site for the technical blogs, and you will see a lot of communication on that site from my people. So with that, thank you very much. I'll be around. If you have any question I can answer, please feel free to stop me and talk to me. Thank you.